You can always learn more. There's so much information on the internet. I want you to consider researching some of these people on your own. It's beyond the scope of this lesson to go into details on every single person here. But you should know Tim, who invented the World Wide Web, the Morgan theory about logic, negative logic and positive logic. John Van Neumann designed the CPU and the addressing, and later on, it became the Harvard architecture. And the classic K&R book about Unix and C from Brian Kernighan and Dennis Ritchie. They made the Unix operating system as a joke on their own time at AT&T so they could play games. And then they developed the C language, which was based on B. And look how popular it was. So be careful what you design and what you build your foundations on, because many times those foundations, whether you think they're good or bad, are here to stay. And Linus, who made the Linux operating system, you should know how that started. And of course James, who made the Java language. So these are just great people to research on your own and learn about. You should know some language concepts. C and C++ and C# and Go and Java and Rust are strongly typed languages. You have to declare up front what a variable is going to be, like you might say integer A, and from then on A is a variable and it's an integer. You cannot assign a floating point to it or anything like that. You declared it and it takes up memory and it's an integer. JavaScript is dynamically typed. You can say var a equals hello world and it's a string, and a couple lines of code later on you can say a equals 1234 or a equals 3.14 pi. It's an integer, it's a float, it's whatever it needs to be. It's determined at runtime. It's a little bit slower because you're changing your data type and it's allocating and deallocating memory. Python, Lua, and PHP have automatic dynamic data types. You don't even have to declare a variable as a or x, y, z. You just start assigning. You say a equals 1.23 and it says, that must be a float because 1.23 is a float, so we'll make a new variable a and we'll make it a float. If it already exists, we'll destroy that one and make the new one. And then of course on the bottom is your assembly language, and Forth comes into that category too, where it's an untyped language. You're just allocating bytes of memory. I just need so many bytes here and so many bytes there, and you can do as you please with them. In fact, in assembly language, there's nothing to keep you, for the most part, especially on the 8-bit processors, from going beyond the length of a string or beyond the length of what you declared. You might declare x is 4 bytes of memory, and you could access the 5th byte or the byte x minus 1 and point to something else. It's kind of like a race car without seat belts. You can go really fast in assembly language, but there's nothing to protect you from doing the wrong thing. There's a great website of a list of computer languages on Wikipedia. I encourage you to go there and take a look at some of these languages and look at the syntaxes. Learning one language is like reading a book by just one author or just speaking English only. When you learn another language, you get different ideas and different concepts. And if you never coded, I encourage you to go to code.org, because everyone should write a program at least once in their life. Even your grandma, she might get hooked. C and C++ are the foundation of much of the current computer syntax that we use today. Even though it wasn't the first computer language, APL from IBM was a computer language, but you needed a special keyboard for it. And then there was BCPL and eventually C, written by AT&T. Go to freecodecamp.org. Learn how to code. Go.dev. Don't put the www in front of go.dev. Go is Google's language called Go. And of course Java and JavaScript. The only 4 things that Java and JavaScript have in common are the letters Java, totally different language. Python, computer science language. Rust language. And of course, dare I mention, Lisp. Lisp, lost in single parentheses. It's kind of a love-hate language. but I think everyone should be aware of it. It used to take years and months, and now it's down to days. In the 60s and 70s, companies spent a long time designing and implementing a computer language. Computers were slow, there weren't as many tools. Today, computers are really fast compared to 50 years ago. And college students get together for pizza and design a new language in a weekend just for fun. Most of these languages, as you've seen on the Wikipedia website, are just for academic purposes. They're not widely used by companies. But the point is, there's so many tools like Yak and Lex that were made to design languages that later got replaced with Bison and Flex. So never stop learning. That's the key. You know, most of these computer languages are procedural. There's a list of functions that do certain things, and those functions call smaller functions, and it's just a hierarchy of little tasks. It's like when you want to clean your office, you'd go through and throw out the junk paperwork and things on your desk that don't make sense, and then you start organizing things, and each thing is kind of a task. And eventually when you do them all, you completed your whole big task. But there's non-procedural languages that give you a different way of thinking. SQL is a structured query language, as you'll see in databases, that it's the way to get information out. It has nothing to do with procedures. It's just the way you ask for the information. And Prolog is worth mentioning because it's used in IBM Watson. It's a non-procedural language. It's great at solving problems by giving it goals. And thanks to the GNU project, you can find almost free compilers, interpreters for almost any language out there. If you're just looking to learn, they may not be the best production tools, but for educational purposes, they're well worth the effort. And of course, these little ones and zeros that control the world, not only are they executable code or numeric values, but sometimes they're just data. Look at the internet. It brought us big data. Everybody tracks you and they know what you buy and what you surf. This is kept in a database, and everyone should have some kind of exposure to at least one database. SQL is the language for querying the database, so I would suggest you go out to learnsql.com, and you should be able to install your own database. MySQL is extremely popular. It's owned by Oracle now, and most of the Linux servers use MySQL. SQLite storing data in files. Postgres SQL is very similar to MySQL, kind of head-to-head competition there. And then if you want to pay for things, there's Microsoft SQL Server and MongoDB. Education is just not learning facts and remembering things, because computers can remember facts, but they can't think. They can only process data. You can think. So education is about training your mind to think. And I always felt this for years. I never even knew Einstein said it until just like a few weeks ago. And I always felt this, that once I stopped learning, I just felt like I was dying. The drive to live was diminishing. So don't die on me, guys. Don't die on me, please. Keep on learning.